Welcome back guys to our video lecture for this week. Now this video lecture is for chapter 3 wherein we will talk about, of course, the voltage and current laws. These laws are very important because most of the time we will be using this. So, you better master this one. Actually, lahat naman ng mga chapters dito sa subjects na to is you really have to master because yung mga previous chapter will be used sa ating next chapters. Okay? So, kapag nalampasan yung ibang chapter without mastering it, sisingilin pa rin kayo pagdating sa dulo. So, again, you master them all. Now, for this chapter specifically, by the way, I will not be using PDF or PowerPoint for this video lecture, okay? I will be just using the ebook so that para somehow ma-preview nyo na rin so that pag nag-study kayo on your own, medyo alam niyo na saan banda mag-focus. Ano? Okay. And nga pala, I hope so you are studying on your own. Okay? I hope so you are reading your book because it is really very hard to hindi ako sigurado kung you can pass this subject without even reading your books. Kapag ka nagawa niyo yun, wow, I salute you, my friend. Okay, anyways, going back. Now, for this chapter, for this video lecture, we are just focusing on these three topics. The remaining topics will be discussed on the next video lecture. Now, for this video lecture, we will talk about circuit terminologies here. We will introduce the concept of node, path, loop, and branch. Also, we'll talk about the Kirchhoff's current law, or known as the KCL, and the Kirchhoff's voltage law, known as the KVL. Okay, so are we ready? Of course. Okay, now first of all, I have here a circuit. Okay, so we have here a circuit. This is just a simple circuit, common ones. Okay, in this circuit we have, what elements do we have? Meron tayong current source, one resistor, second resistor, third and fourth resistors. We have 4 resistors. Now, if I'm gonna ask you, can you see this point here? Nakikita niyo ba to? Of course. Now, if I'm gonna ask you, in the real world or sa actual world, ano ba itong, what does this implies? Ano bang ibig sabihin nito? So, sa real world, kumbaga, these are just the solder joints. Tama po ba? Kapag ka nag-connect ka ng circuit na ganito, then isusolda mo dito so that they would have connection. Okay? So, sa real world, this is solder joints. So, kumbaga, if you will assemble this in the real world, isusolda mo dito 1, isusolda mo rin dito 2, isusolda mo rin dito 3. Okay? So, meron kang tatlong solder joints. And because hindi naman ito real world, hindi naman talaga to actual devices, these are just circuit diagrams. Now, the circuit diagrams ang corresponding ng ating solder joints is a node. Okay? Ang tawag natin dito is node. So, to define it formally, node means a point of which 2 or more elements have a common connection. It is a point in your circuit wherein 2 or more elements have common connection. So again, going back, where is the point? So if this is our point, 2 or more elements that have connection. So asa na yung 2 or more elements which has connection? If this is our element 1, connected siya sa element na to. Tama po ba? Yes, because if you notice, meron silang connection. And this element is also connected to the rest, and so with this one. So this node allows connection between 2 or more elements. Alright, so that is your node. Now, careful lang tayo because pagdating sa nodes, some students is nalilito sila. They get tricked. Say for example, I have here second circuit. If I'm gonna ask you how many nodes do we have, what is your guess? Okay, you might say, ma'am, we have 1, 2, 3, 4 nodes. Is that your answer? If that is your answer, well, that is wrong. Okay, for this circuit, still we only have 1, 2, and 3 nodes. Ma'am, how come? But I can see 1, 2, 3, 4 points. Eh sabi, node is a point. Tama ba? Where 2 or more elements are connected. Yes, this is visually, or you can see 3 points, but yung official node lang,
is only 3. Kasi po, itong node na to and node na to are the same. Bakit the same? Tingnan natin. How many elements is connected on this node? We have 1, 2, 3, 4. What about on the other node? We also have 1, 2, 3, 4. Going back to this node, ano yung mga elements na nakakonect sa kanya? We have 1 current supply and 3 resistors. For this one, we also have 1 current supply and 3 resistors. So, ibig sabihin, the same lang sila kasi same yung mga elements na nakakonect sa kanila, same din yung number of elements na, ng mga elements na nakakonect sa kanila. So, they're just equal. And pag equal sila, anong ibig sabihin? Kapag ka-equal sila, you can just count it as 1. Ibig sabihin, isang node lang to. Although, node din naman talaga to, ano? But then, yung official count natin ng nodes is 1 lang itong isa. Ibig sabihin, ano implication nun kapag ka-the same yung node? Kapag ka-the same, ibig sabihin, pwede natin i-combine tong dalawa. Pwedeng i-merge. At kapag ka-merge natin to, kinumbine natin itong two nodes, we have this equivalent circuit. Tama po ba? Again, kapag ka ipaghiwalay mo yan, still, magiging ganito yung itsura, still isang node pa rin yan. So, 1 pa rin yung count. Okay? So, please do not be confused. Okay po. Now, let's proceed. So, next we have here. Let's go back to our circuit. So say for example, I start here and then I will move, okay? I will move from here, I will go here and there and then goes to the resistor and to node 3. Now if I move like that, I'm creating what is called a path, okay? That is a path. Again, if I'll start here and then I'll move right here to this node, into this element, into another node, that is a path. Bakit? Ano ba ang path? We have this definition. So, upon going over the circuit, if no node was encountered more than once, then the set of nodes and elements that we have passed through is defined as path. Okay? Kapag ka walang element daw na nadaanan more than once, then that is a path. May nadaanan ba tayo more than once? So, dito muna, nagsimula tayo dito, papunta doon. May element ba or node na nadaanan more than once? Wala. Kapag wala, then that is a path. So, again, I'll start here. And then I'll go to this element, to the next node, to another element, and a node, and an element, and then I'll go back here. What have you noticed? Yung starting node ko, doon din ako natapos. Anong tawag mo doon? Is that a path? Ang tawag mo doon, that's special yon. Ang tawag mo doon ay closed path or loop. It's still a path, pero specifically it's a closed path because yung starting mo doon, dun yung ending mo. And it's also called a loop. Okay? Kung saan ka nagsimula, doon ka natapos, that is a loop. Kapag ka no node is encountered more than once, that is a path. Alright? So another example of loop. Say for example, I'll start here and then I go right here on this element, another node, another resistor, a node, a resistor, and go back here. What is that? Is it a loop or a path? That is a loop. Okay? Because doon ako natapos kung saan ako nagsimula. Path. Another example of path is, say for example, we have it here. And then we'll go to this resistor right here. And on this resistor, another node, and go back here and here. And I'll get back there. Then I'll stop here. So, anong tawag natin doon? Ulitin ko ha. Let's have drawing tool. Okay. Ulitin natin. So, magsisimula ako dito. I'll travel from there. Punta ako dito. Here. Right there. And I'll stop here. Question. Is this a path? A loop rather. Kung saan ba ako nagsimula, dun ba ako natapos? Hindi. So, is this a loop? No. Is this a path? path ba to? Anong sabi sa path? No node is encountered more than once. Ito once na encounter, check. Ito once na encounter, check. Ito, how many times do we encounter this node? Twice. So, ibig sabihin, hindi na siya under sa path. So, this is neither a loop nor a path. Okay? So, dapat sa path, no node is encountered more than once. Now, what if the same, no? Punta tayo dito, right here, and then here, and then here, and then we go up here and here. Okay. Now, if you notice, kung saan ako nagsimula, doon din ako natapos. Paano nga, ano nga ulit pagka ganun? Ang tawag mo? Loop. Now, question, is this a loop? Did I made a loop? Ulitin ko, ha? So, from here, punta ako dito, right here, and then here, go back sa taas, pabalik sa pinanggalingan ko. Is that a loop? No, that is not a loop. Pero ma'am, di ba sabi, if saan ka nagsimula, doon ka natapos, then that is a loop. Eh, ba't ito hindi siya loop? Kasi, class, don't forget na a loop, oops, tinakpan. A loop must be a path. Okay? A loop must be a path. So, kailangan path din siya, yung loop natin. And in this case, pagdaan niya pa lang dito, this is not a path anymore. Okay? So, although bumalik siya sa pinanggalingan niya, but still, hindi yun path kasi there is a node na more than once na siya na-encounter. So, that is not included as a loop. Okay? Please don't forget that the loop must be a path. Okay? Now, another term is called the branch. Well, branch. Another term is called branch. So, we define a branch as a single path in a network. Single path lang siya. Okay, still a path pa rin siya, pero single lang, composed of, meron lang siyang one element, simple element, and a node at each of that element. Isang element lang and the node at each end of that element. So, for example, in here, meron tayong branches dito. Asan yung ating branch? Sabi isang element daw. So, isang element and the node sa dulo ng element. So, ibig sabihin, this is our oopsie. Ibig sabihin, this is one branch. To. Ayun. Asan pa? Ito. Another branch. Asan pa? Ito, branch. Isang element and sa nodes sa dulo. Oh my God, what am I doing? Asan pa? Ito. Is this a branch? No, walang element dyan. Eto, is this a branch? Yes. Eto ma'am, branch po ba to? No, kasi more than one element. Okay? Wow, what a drawing. So again, yung branch natin is dapat meron siyang one element and two nodes dun sa kanyang dulo. Two nodes, bawat dulo. Okay? So I hope that is clear. So how many branches do we have here? Erase ko lang muna. How many branches do we have for this circuit? So we have 1, 2, 3, 4, 5 branches. All right? Questions? If you have questions, comment it down below. So now, ladies and gentlemen, allow you to introduce you to Kirchhoff's current law. So, eto na si current law. So, sa electronics nyo, may KVL din na discuss doon. So, it's important na panuorin nyo muna unahin nyo muna tong sa circuits. Ano? Kasi, it's assumed doon na alam nyo na paano mag-KVL and KCL. So, unahin nyo muna to. So, again, going back. So, this Kirchhoff's law is by Gustav Robert Kirchhoff. Ayan. It's named after Gustav Robert Kirchhoff. Oh my God, ba't di ko napansin dati na double F and double H pala to? Okay, so anyways, so your Kirchhoff is spelled double F and double H. Oh my God, ngayon ko lang nalaman. Anyways, okay, so ano ba sinasabi? Ano bang pinaglalaban nitong Kirchhoff's current law? So sabi ni Kirchhoff, ni Uncle Kirchhoff, sabi niya, the algebraic sum of all the elements entering any node is 0. The algebraic sum of all the current. So yung sum daw ng lahat ng current na pumapasok sa node is 0. So, ibig sabihin, take a look at this node. Kapag ka may current doon na pumasok dito, pumasok dyan, pumasok dyan, pumasok dyan, kapag ka you total them all, that should be equal to 0. Okay? Ma'am, paano nagka-0? I-add nga siya. Paano siya naging 0? Because class, kapag ka kasi sa isang node, kapag ka may pumasok na current dyan, meron talagang lumalabas. Okay? Eh kapag ka iba yung direction, that is negative, yung sign ng ating current. So pag in-add mo sila, somehow they would result to 0. Okay? So just take note na mayroong positive and negative um, yung ating current, no? So pwede siya, possible siya na maging 0, yung sum niya. So, as of the moment, tandaan nyo, nasabi ni Uncle Gustav Robert Kirchhoff na may double F and double H that the algebraic sum of all the currents na pumapasok do sa node is 0. Ibig sabihin, pag i-total mo lahat ng current na pumapasok sa node, that is equal to 0. Okay. So, a node daw is not a circuit element. And it certainly cannot store, destroy, or generate charge. Just remember this. So, ang node natin, hindi po siya circuit element. Ibig sabihin, hindi po siya nakakapag-store. Okay? Hindi siya, saan ba galing kasi itong law niya? Ano bang pinanghuhugutan? Kasi daw yung node, hindi circuit element. And since hindi siya circuit element, hindi siya nakakapag-store, hindi niya rin naman sinisira, at hindi rin siya gumagawa ng charge. So, kung ano lang yung pumapasok sa kanya, lumalabas lang din. Wala siyang ginagawa. Okay? Walang ginagawa itong si Node. Parang security guard lang. May pumapasok na tao, edi papasukin mo, may lumalabas, edi palabasin mo. Wala siyang kinikidnap na tao, wala siyang, yeah, ganun. Anyways, that's weird. So, ganito na lang. Halimbawa, tubo ito. Okay. Water pipes ito. Meron tayong water pipes, 4 na water pipes na connected siya sa center. Okay. Now, say for example, may tubig na pumapasok dito. May pumapasok din dito. Do you think itong lahat ba na lahat ng tubo, itong 4 na water pipes na to, papasok lahat ng tubig? Do you think papasok to, papasok, papasok, papasok ditong isa? No, kasi kung lahat sila papasok, what will happen? It will burst, 'di ba? So somehow siguro yung iba papasok, yung iba palabas. And yung total lang pumapasok is equal sa total sa lumalabas. 'Di ba? So ganun yung analogy ng ating Kirchhoff's current law na yung node, lahat ng pumapasok na current is yun lang din yung lumalabas na current. So, no, yun na ngayon yung sinasabi niya that the algebraic sum of all the current, okay, of all the current entering any node is 0. Kasi hindi pwedeng papasok silang lahat. Hindi rin naman pwedeng palabas silang lahat, 'di ba? Imagine, may lumalabas na tubig diyan, may lumalabas dito, dito, at dito. Eh, saan galing yung tubig? Wow naman, ano to? Merong magical source of water, ganon. So, hindi pwede. Hindi pwedeng papasok lahat, hindi pwedeng palabas lahat. Alright? Now, algebraically, ganito yung itsura niya. If we will denote this as IA, IB ito, I is for current, ito yung current C natin, IC, current TID. If we will look at it algebraically, ganito lang siya. No? Meron daw tayong IA plus IB. Ba't na IA plus IB, itong dalawa na papasok, plus, kasi sum, sabi natin ano, plus IC, but negative. Ganito yon. Kapag kapalabas, then that's negative. Pag papasok, positive. Okay? So, plus IC, negative IC kasi palabas, plus negative ID kasi papasok, and that should be equal to 0. Alright? So, anong ibig sabihin ng equation na to? Ibig sabihin, kapag ka alam mo yung one of the three, ganito. Kapag ka alam mo yung ilan yung pumasok, say for example, this is 2, this is 2. And you know na ang lumalabas dito is 1. So, that gives you an idea na dito sa kabila, may lumalabas dito na, ilan? 4 yung papasok. Kasi 2 plus 2. May lumabas dito na 1. Ilan yung dito sa kabila? 3. Okay? Parang gano'n. It just give you an idea. Do not really just focus on the number, but focus on the sense. Para pag nag-solve kayo sa susunod, hindi agad-agad, hindi solve nang solve. Meron ding analysis. Okay? Okay. So, pwede mo din doon siyang tingnan in a different angle. Okay. Sabi din niya, yung law pwede din siyang, could be equally applied, pwede din siyang gamitin to the algebraic sum of the currents leaving the node. It's not just the current entering the node, but same is true sa current leaving the node. So, kapag ka leaving the node tayo, meron kang negative IA plus negative IB plus IC plus ID is equal to 0. Ma'am, bakit yung IA na ngayon yung negative, yung IB na yung IA and IB na yung negative, yung isa is positive? Kasi with respect tayo sa living, okay? We take it as living, so kumbaga yun yung gawin nating positive. Okay, so kapag ka hindi siya living, entering siya, edi yun yung negative. Etong sa kabila kasi sabi natin, the sum of the currents entering the node. So yung positive natin, kasi we're using the word entering, edi yung mga pumapasok. Kapag ka lumabas, edi that's negative. Okay? So, ganun lang. Anyways, it doesn't matter naman kung positive or negative. Basta consistent ka lang. Basta kung inassign mo na entering is positive, edi, why not? Diba? Basta consistent ka lang. Pwede din siyang ganito, children. Pwede din siyang ganito pagkasulat para hindi ka malito. Kasi, oh my God, sino ba si positive? Sino si negative? 'Di ba? Baka malito ka. Ganito, pwede na lang ganito. Pwede na on the right side, yun yung ating mga positive. On the left side, I'm sorry, yung sa kabilang side, yun yung ating mga entering is equal to leaving. Ganun na lang. Okay? Although, same lang naman to, kapag tinranspose mo itong dalawa sa kabila, then you'll have positive na sila both. Itong dalawa, pag tinranspose mo sa kabila, positive na dito. So, parang ganito lang. So, para hindi na kayo malito, isipin niya lang KCL is equal to, or states that the product entering, the current entering, etong mga I and IB entering is equal to the current living. Oh, wala ka nang isiping positive, negative. Okay? So, ganun na lang. Again, sabi ni Kirchhoff, that the current entering is equal to the current living. Okay? Now, ladies and gentlemen, ayun po yung ating Kirchhoff's current law. Ang ganda, di ba? Maganda ba? Tingnan natin. So, we'll use it on our example. So, meron tayong example dito. Hindi ko muna siya isusolve talagang hand ha. Ano lang muna, conceptually lang muna itong ating pagsusolve. Siguro I will just upload a video on examples, more examples on how do we solve this type of problem na talagang mano-mano. Okay, ang gagawin ko is conceptual lang, kumbaga yung paano siya gagawin, ganun, paano lang. Then kayo na bahala mag-practice. Okay? Okay. Now for the circuit, this is the circuit. Compute the current through your resistor R3. Current doon ni R3. If it is known to have the voltage source supplies a current 3 ampere. Bakit 3 ampere to? Okay. So, yung voltage daw, source, ito yung voltage source po natin. Supplies a current of 3 ampere. Wow, bonus na to. Yung voltage source, binigay na sa atin na meron daw siyang 3 ampere na current. Ayun, magic. So, meron tayong 3 ampere dito. So, tingnan natin, ano? Meron kang 3 ampere dito and then hinahanap is yung current through this. So, may label na siya. So, ibig sabihin, hahanapin daw natin. Let me zoom in. Hahanapin daw natin. Oopsie. Hahanapin daw natin itong I. Okay? Hanapin si I. That is the goal. So, given na natin, alam na natin na may current na dumadaan dito sa ating R2. R2, meron siyang 2 ampere. But before that, apply muna natin yung na-discuss natin kanina. So, question. How many branches does this circuit has? So, ito ay meron siyang 1, 2, 3, 4, 5 branches. Very good. Question. How many nodes does this circuit has? How many nodes? Come on, make a guess. Pause the video and make a guess. The answer is 3. What? Bakit 3? Bakit 3? Kasi meron tayong node right here. This is our first node. Agree? O, meron siyang 2 elements connected sa kanya. This is our second node. All the way right here. Ito, isang node lang to. Remember, for this node, ilang elements nakakonect? 1, 2, 3, 4. For this node, 1, 2, 3, 4. Yung mga elements na nakakonect sa kanila, the same. So, equal yan sila. And this one is also one node. Okay? So, for this circuit, officially, we have 3 nodes. Alright? So, let me just delete it. Okay. Now, anong gagawin natin? Of course, because inintroduce na si KCL, malamang gagamitin natin siya. Ano? So, take a look at this node. Ito, napakagandang starting to na node. Current entering is current leaving. Ano ba yung mga pumapasok sa kanya na current? Meron tong 3 ampere na papasok. 2 ampere dito. Dito unknown. Ito, given. So, that gives us or that leads us to KCL, 'di ba? So sabi sa KCL, ano nga ulit 'yan? Current entering is equal to current leaving. So ano ba yung mga considering this node, ano ba yung mga pumapasok sa kanya na current? So we have 3 ampere pumapasok plus ano pa? 5 ampere. Okay? So 3 ampere plus 5 ampere, hindi ko na isusulat ha kasi ang hirap, is equal to current leaving. Ano ba yung pagpalabas na current? Itong dalawa. So, 3 ampere plus 5 ampere is equal to 2 ampere plus I. So, you have one equation, one unknown. Ibig sabihin yung I natin is equal to 6 ampere. So, for this circuit, our I here has 6 ampere. So, ganun lang kadali ang buhay dito sa circuits. Check natin. And this is our answer. Alright? Now, dito sa book, notice yung solution niya. Okay. So, sa kanya, pwede din naman, kasi node din naman to, tsaka node, pero officially, the same lang siya. But, node din naman to. So, kung dito ka magfo-focus, nilabel niyo yung current dito sa gitna as IR2 minus 2 ampere, pwede din naman, so, meron kang dalawang analysis dito for this node and this node. Okay. Pero medyo tingnan mo, medyo complicated na siya. But if you were able to identify na itong dalawang nodes na ito is just the same, mas mapapadali ang buhay. So una, talagang, kasi pag nag-solve ka agad, edi pa isa-isa, how many nodes yung nakikita mo, yun din ang nodes na i-analyze mo. Pero pag pinlano mo muna, determine mo kung ilan ba talaga yung actual or official nodes, then mas madali siya. Okay? So plano muna bago sa lakay. Okay, so you have your practice. Kayo na bahala sa practice. Okay? Bigyan ko lang kayo ng clue. Go over muna tayo. Okay. So, sabi dito sa practice, count the number of branches and nodes in the circuit. So, how many branches do we have? Easy. 1, 2, 3, 4, 5. 5 branches. How many nodes do we have? Pause the video. Make a guess. Yes, we have 3 nodes. Saan yung nodes na yan? Eto, the same lang to. Okay? So, this is 1 node, 2, and then 3. The same lang tong mga nodes dito. So, officially, there are 3 nodes. Although, nodes din naman to. Node din to. Node, node. Pero yung mga equal nodes, you have to consider as 1. Kasi pag na-identify mo siya again, na isa lang sila, na the same sila, then mas madali ang buhay. Ito ang dali nito. Kasi sabi niya, merong, itong Ix is 3 ampere. So, given to, this is 3 ampere. Ito na naman. 3 ampere. Ito, the same node. Okay? Isipin natin as isang node yan. Ito, given na yung 18 volt source delivers. Delivers, so ibig sabihin, saan papunta yung current natin dito? Ganun ba? No! Kasi according to conventional flow, yung current natin sa ating voltage supply is from negative to positive. So, meron siyang ganyan, and that is 8 ampere daw. Okay? That is 8 ampere. And meron din siyang 13 ampere dito. Oh my God, this is a bonus question. So, current entering, current leaving. Okay, ganito muna. So, it's important kasi it's important to identify whether the current in that certain element is entering or leaving. Okay? So, leaving, hindi living. Okay, so for this, first, voltage supply, of course, wala namang question. Alam mo, always, dapat alam mo, na yung current is from negative to positive. So, this is the direction. This one kasi in-identify niya na napapasok doon yung current, di papasok doon. Somehow papasok to because meron siyang voltage supply dito. Although hindi siya given, pero sinabi niya na papasok doon. Which makes sense kasi nga, kapag yung voltage supply, pag ganun yung direction ng current, from negative to positive. Eh, yung current dito, same lang din naman to sa current dito. Alright? Now, ngayon, yung mga resistors, kapag ka hindi siya na-label class, children, kapag ka hindi siya na-label, it's always leaving yung current is always leaving the node. So, we'll assume that RA is palabas. Alright? So, meron tayong current entering. Saan yung mga entering? Itong 8 ampere and 13 ampere is equal to current leaving, which is 3 IRA and 3 ampere. So, one equation mo na known, then you get your current. At kapag ka nakuha mo na yung current mo, kapag ka nakuha mo na itong current mo dito, using Ohm's law, which is V is equal to IR, you would get your RA. Okay? Paano ba ang formula ng RA? Because V is equal to IR, and we're looking for R is therefore equal to, R is equal to V over I. And V is equal to, kasi nakaparallel siya sa 18, this is just 18. Oh my God. Sorry. This is just 18 divided by I na na-solve na natin. Yeah, kung ano yung na-solve mo. And then you get the R. Okay, whatever the value na-solve mo sa ano, then you'll get your R, which should probably be 1 ohms. Okay? So, I hope easy lang to sa inyo. So, additional, sabi niya, a compact expression of Kirchhoff's current law is, pwede din daw siya na ganito yung Kirchhoff's current law. Pwede siyang sabihin na that the summation of the currents In is equal to 0. From N is equal to the summation of In from N is equal to 0 to infinity is equal to 0. The summation of all the currents tong, sabi niya, summation of all the currents sa ating node is equal to 0. Alright? So now you're now ready for our second law, which is kay Kirchhoff pa rin na double F and double H, which is the Kirchhoff's voltage law. So sabi sa Kirchhoff's voltage law, sabi niya, the algebraic sum of all the voltages around a closed path is 0. Say for example, these are elements. Okay? Ma'am, ba't ganyan yung itsura ng element? Ano lang siya? It could be any element. Okay? Basta sa circuit, kapag ganitong drawing, shapeless object, it means element. So, kapag meron na tayong element, lahat na ng sum ng mga voltages across that is 0. So, ibig sabihin, pag inad ko yung voltage nito, plus ito, that's 0. Kapag, basta closed path, or loop siya. Okay? Again, sabi ni KVL, the algebraic sum of all the voltage around any closed path is 0. Okay. Kasi daw, say for example, on this circuit, meron kang, say for example, meron kang 1 coulomb at point A at ipupush natin, dadalhin natin siya dito. Kapag pinush natin yung charge na yon, which is, say for example, yung mga electrons, pinush natin siya papunta dito sa point B, it requires energy. Tama po ba? And sabi ni Kirchhoff's na yung energy required, pag ipupush natin yung 1 coulomb of charge from here to point B, pag dito tayo, pwede tayong dumaan dito, di ba? Pwede din tayong dumaan dito. Still, darating pa rin tayo sa B. Tama po ba? Pero ang sabi niya, yung energy required, pag dito mo siya pinadaan, wherein equal siya sa V1, is equal pa rin sa energy na magagamit mo kapag dito mo siya pinadaan, which is equal to V2 plus negative na to kasi we enter into the negative terminal plus negative V3. Okay? Kahit saan ka dumaan, still, the same pa rin daw yung amount of energy na may expend. Kaya, meron tayong ganitong formula. Sabi dito, yung energy or yung V1 natin, ito, pagka dito ka dumaan sa kabila, kasi positive to. Kung ano yung positive na sign na encounter mo, yun yung sign na dadalhin mo. Okay? So, this is positive V1 is equal siya sa positive V2 minus V3. So, eto na yun. Okay? Now, ma'am, asa na ba't hindi siya match dun sa sinabi niya that the algebraic sum of all the voltages around any closed path is 0. So, kapag ganyan, edi pag tinranspose mo lang tong mga, eto, V1, V2 mo dito, then just equate it to 0. Or, pwede din siya na ganito, na yung V1 mo plus V2 plus V3, lahat ng voltages mo sa iyong closed path or loop is equal to 0. And po, meron din siyang ganitong notation that the summation of all the voltages is just equal to 0 from n is equal to 1 to n. Okay? So, ang pinaka-final thought sa KVL, again, summation of all the voltages is equal to 0. So, pwede kang gumawa ng loop. Say, for example, starting here, ikutin mo yung loop mo, tapos bumalik ka dyan. Then, i-record mo lahat ng voltage na may encounter mo, then equate it to 0. Say, for example, pupunta ka dito. So, anong voltage meron ka? Meron kang negative 1, negative V1. Papunta dito, this is negative V2. Wait, ulitin ko. So, from here, punta ka dito. So, meron kang negative V1. Papunta dito until meron kang positive V2. Papunta dito wherein meron kang negative V3. Then close. Is equal to 0. Ganon. Okay? So, say for example, halimbawa lang meron tong negative 1. Oopsie. Negative 1. Tapos tong isa, halimbawa lang, meron siyang positive 2 volts. Then, question is, ano ba yung value ng V3 natin? So, kapag ka ganito, kasi merong voltage, may voltage, pwede tayong mag-KVL. So, according to our KVL, halimbawa, mag-start tayo dito. So, we have positive to. Halimbawa, positive 1. So, kasi negative yung unang terminal na encounter natin. So, meron tayong negative 1. Next is positive 2 minus V3 is equal to 0. And that gives us a V3 which is equal to, ano value ng V3 natin? 1 volt. Okay? So, para pag niloop natin siya, say for example, 1 volt to according sa our calculation. So, meron tayong negative 1 plus 2, that is 1 minus 1, that is 0. So, yung total voltage natin is equal to 0. Alright? Naintindihan po ba? O kinomplicate ko lang? I hope so, naintindihan. So, we have here example. In the circuit 3.6, find Vx and Ix. Ayun, hanapin daw natin sa circuit na to si Vx and si Ix. So, again, apply natin yung mga natutunan natin sa taas. How many nodes do we have? Pause the video, make a guess. We have 3 nodes. 1, 2, 3. How many branches do we have? 1, 2, 3. Very good. So, on this circuit, meron tayong dalawang voltage source and 1 load resistor. Okay? So, question is, ano daw ba yung Vx at saka Ix? So far, yung mga techniques na pa lang na pwede nyong gamitin is meron tayong Ohm's Law. Okay? Meron tayong Ohm's Law. Meron tayong KVL and KCL. And yun. Yun lang yung mga gagamitin natin. So, una, paano ba? Hanapin daw si Vx. Tingnan mo muna ano yung applicable. Ma'am, gagawa ako ng KCL. O, sige, mag-KCL ka. So, dito na node. Okay. So, current entering mo ay, hindi ko pa alam, ma'am, basta Ix. Okay. Which is equal to, yung lumalabas din naman dito is still Ix pa rin naman. Ano? So, Ix is equal to Ix. Edi wala kang napala. So, usually, kapag ganito, na dalawa lang naman yung nakakonect sa kanya, hindi applicable yung KCL kasi ano yung pumasok, yun lang din yung lumalabas. So, wala kang useful na equation na makukuha. See, for example, Ix yung pumasok, Ix yung lumabas, hindi mo pa rin naman alam yung Ix, di ba? See, for example, alam mo na, for example, 2 tong current dito. 2 yung pumasok, 2 yung lumabas. Ano naman yung napala mo dun? So, hindi mo siya magagamit. Okay? So, ano kaya pwedeng gamitin dito? Look at your circuit. So, malamang pwede kong gamitin dito si KVL. Kasi sa KVL, lahat daw ng voltage is equal to 0. So, alam ko tong voltage na to, plus tong voltage na to, which is known, plus itong unknown voltage is equal to 0. So, meron akong one unknown lang sa aking equation. Thus, makukuha ko na si Vx. 'Di ba? So, ayun. So, halimbawa, try natin i-solve. Maglo-loop tayo starting dito. So we have, yung unang na-encounter is negative. So we have the right negative 5. Again, please excuse my writing. Negative 5. Negative din naman yung na-encounter. Minus 7. Next is plus Vx is equal to 0. Oh my god. Now Vx is equal to, please excuse the writing, Vx is equal to 12 volts. Which makes sense. Kasi yung Vx natin, siya lang naman yung load natin. So malamang kasi supply tong dalawa, sa kanya napunta lahat ng voltage. Okay? So check natin kung talagang 12 volts ba yung ating Vx. Okay? Check. We have here 12 volts. Now, we are left with Ix. Ano ba itong ating Ix? So si Ix natin, of course, yung Ix natin is yung current na dumadaloy sa ating voltage na 5 volts at saka dito. So, same lang kasi series naman to, ano? So, kung makukuha natin yung current through our resistor, then we get our Ix. So, our Ix is equal to, what's the formula? According to your Ohm's law, V is equal to IR. So, I is equal to V over R. So, that's equal to VR over R. And that gives us VR, which is equal to 12 volts divided by 100. And that gives us 0.12 ampere. Ayun. Let's check. 0.12 ampere or 120 milliampere is the same. Okay? That is your KVL. So you have here your example, practice. Again, you practice this. Anyway, sa practice, the same lang din naman yung given. The same lang naman yung circuit, pinalitan lang yung given. Yakang-yaka niya to. Again, you will not understand, you will not really master the concepts here kung hindi ka magsosolve. So again, I would remind you to really, really solve the problems on the book. The book is your best friend. Alright? So that is your Kirchhoff's voltage law. I hope klaro siya. And additional lang, ang current natin, kapag sinabi nating current, the term to be used is it is flowing through the circuit element. Through kasi dumadaan siya sa circuit element. Kapag ka voltage naman yung pinag-uusapan, it is a measure of potential energy difference across the element. Okay? Kasi hindi naman siya dumadaan sa element eh. But andyan siya across your element. So again, current is through the element. A voltage is across the element. Okay. So this week, I will not give you assessments, but I just hope just to give you time to really master this one. Okay? So I hope you do your part to master this para pagka next natin ng mga master niyo na siya. Okay? Di na kayo mahirapan. Di na madagdagan yung mga problema niyo. I hope you are responsible enough to um, practice solving kahit na wala tayong assessment, kahit na wala tayong assignment. Okay? Malay mo, magpa-surprise quiz ako next week. Malay natin. So again, you master this and I'll see you in my next video lecture. Right? Bye guys.